Welcome to Real GMAT Problems, episode 41. Doing real GMAT problems is one of the most data-backed ways to make test day go well, so let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you would like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams. So these are going to be very, very similar to what you will see on your official GMAT. And that's true of the current edition of the official guide, which is a great part of pretty much everybody's prep process. I'll give you a chance to work through the solution on your own if you'd like, and then I'm going to discuss my thoughts on what I recommend learning and taking away from each one. I will also recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You may not be able to execute all the steps in your head if you're on the go, but just do your best. If you are in a situation where you can physically write down what you would on test day, that's definitely ideal. We've done a ton of problems together in this series, and we're going to start getting into some more challenging questions, just like we have the past few episodes. I'm still going to begin with a simpler warm-up problem, but then we'll ramp up the difficulty a little bit. If you find these a little too tough, then I would recommend going back to any of the earlier episodes in this series. Anything 35 and earlier will have a little bit lower difficulty level questions if you want to ramp up, and then return here whenever you're ready. I believe we've been having success sticking with specific topics through some of the recent series, and so we're going to do that today as well. We're going to talk about sequences. I'm going to talk through a few basic concepts, and we're going to save sequence notation, which is a big part of sequences, for a different episode. Today, I'm just going to focus on lists of numbers and a few techniques for those kinds of questions that I think you're going to find super, super helpful. So I'll read our warm-up problem here in a moment. And again, recommend pausing after I read and doing your best to solve. Question 1. In the sequence above, and I'll read the numbers for you in a minute, each term after the first is 1/2 of the preceding term. What is the least term of the sequence that is greater than 1? I'll read that again in a moment. The terms in the list are 240, 120, 60, and 30. Okay, 240, 120, 60, 30. In the sequence above, each term after the first is 1/2 of the preceding term. What is the least term of the sequence that is greater than 1? Option A is 32 over 15. Option B is 16 over 15. Option C is 15 over 8. Option D is 15 over 4. And option E is 15 over 2. Again, recommend pausing. I'm going to jump right into my commentary here so we don't have a bunch of dead air. Great warm-up problem for sequences. It introduces a couple foundational concepts that I think you're going to find valuable across the difficulty level spectrum. They're simple principles, but we'll take some time to talk through them anyway because they're so helpful. First, the basics. I've spoken about this at length in the series. These definitely apply. Make sure you're always writing what's given and asked. There aren't too many pitfalls in this question, but the ones that are there definitely seem to revolve around how folks are visualizing the information. We'll return to that idea in a moment, but basically writing what's given and asked is going to greatly reduce the odds that you're going to fall into any of the traps. Let's walk through a good correct solution path first, and then we'll return to some of those pitfalls. So again, writing what's given and asked, let's write the first few terms, 240, 120, 60, 30. Those are given. And then we'll note that we're going to continue to multiply by 1/2 as we move through the sequence. And you can notate that however it makes sense to you. It could be like half math, half English. I'll give an example of that in a moment. Or you could do like times 1/2, pure math, up to you. Whatever makes sense to you, just make sure that it's clear. And then we'll also note that the question's asking for the least term that is greater than 1. It's definitely easy to mix that part up. Now, if we execute well, the rest of the problem is pretty straightforward. We're just going to keep multiplying these numbers by 1/2 or dividing by 2, same thing, until we get what we want. Just because it's simple, though, does not necessarily mean that it's easy. And if you've been studying for a while, you may have seen this in some other questions. So, um, as long as you focus on clearly writing out your computation, you should be in good shape. So that's what we're going to do. So we'll start with 30 over 2. I'd probably just rewrite that as 15. We divide that one by 2. That next term is going to be 15 over 2. It's okay to write it as 7.5, but usually decimals are going to make the math in these questions a little bit tougher and a little bit more error prone for folks. We've gone through a few of examples like that in this series already. If you're already having success with decimals and you're not making any mistakes with them ever, then by all means use those. But if you have found that decimal notation is just, I don't know, it's just not resonating with you, that's super common. And it's totally fine to just keep things in fraction form. So for me personally, I haven't had the best luck with decimals. So I would keep it as just 15 over 2 for the next term. And we're going to divide that by 2, aka multiply 1 by 1/2 to get the next term. The next term would be 15 over 4. And we're still bigger than 1. So I'm going to multiply by 1/2 again. That would be 15 over 8, still bigger than 1. So I'm going to multiply 15 over 8 by 1/2 to get the next term, which is 15 over 16. And 15 over 16 is the first term in the sequence that's less than 1. So what number is right before that? That's 15 over 8, and that's going to be our correct answer, which is option C, as in Charlie. So what are some good tips there? Probably the biggest one is trying to avoid the decimal math unless you're super comfortable with it. I think a lot of us are conditioned to do decimal math from school because we have access to a calculator, and calculators tend to prefer decimal expressions. But because we don't have access to a calculator on the quant section on the GMAT, again, I've just found it to be super, super risky. I even gave up trying to understand why, and just basically recommend that you use fractions unless, again, you're having insane success with decimals, in which case, don't change what you're doing. Yeah, even if the problem presents questions as or numbers as decimals, I'd recommend turning them into fraction form to the maximum extent that's reasonable. Sometimes there's like questions that revolve around the fact that it's a decimal, and so those might be the exception, but by and large, like 99% of the time, I think you're going to have better results with fractions if you're like most people. So that one tip, even though it's seemingly small and probably not like a game changer on this question, it could definitely be the reason that you're either right or wrong, one way or the other. And I've just seen it happen thousands of times. So if you struggle with the computation a little bit, hopefully that helps. In terms of places where it looks like folks are going wrong, it looks like a good number of us pick option D as in Delta. Not an overwhelming number, but a good number of us pick that. And a good number of us also pick E as in Echo. So let me just remind you what those values are in case you're on the pure audio feed. So C is our correct answer. That's 15 over 8. D is 15 over 4. That's the previous term in the sequence. And E is 15 over 2, which is the 2 terms previous in the sequence. And about the same number of people pick D and E. About 5% of us go for D. About 5% of us go for E. So I thought about it. I'm not 100% sure why that's happening, but my guess is that people are thinking that as soon as the result is not an integer, then they're just making that mean that it's less than 1. So that could be a reasonable way that people are getting to option E, which if you think about 15 over 2, like that's much, much bigger than 1. But it's the first term in the sequence that's not an integer, so people might be thinking like, oh, there's a fraction bar there or there's a decimal there. Sorry. And so then maybe they're mixing up that with being greater than 1, just the fact that it's a non-integer. That's definitely one possibility. Or they might just be forgetting what the question's asking, and they might just be thinking like they might start by thinking which one's greater than 1, and then that can transform quite easily into their in their mind to like which one's not an integer. So I could see that being a big reason that people pick E. Um, but I think like stepping back from it, it just doesn't seem to most folks that I've worked with over the years that that's a mistake that's even possible for them to make. Like just when you're in the practice room, I think it's just a very different feeling than when you're on the actual exam. But the time pressure can be significant, and there's also the fact that the test can sometimes just like wear us down with how long and intense it is. So I've just found that people can make those kinds of errors if they don't have a really solid system for preventing them that they have rehearsed a lot in practice. You want to think about conditioning yourself to have good habits, and particularly good habits of visualizing things well, so that if something goes off the rails or you make a mistake, you can like literally see yourself making the mistake on the paper. That's a really, really good safety net. Even if you tend not to make those mistakes, I think there's a lot of value in that as like an insurance policy, if that makes sense. And I made just a truly monumental number of those mistakes back in my day when I was in your shoes. And so I could have really used someone telling me like, hey man, have you thought about writing that down a little more clearly? Like I could have really used that. So I hope that that's helpful for you. So if you ended up going for either of those answers, um, it's a good reason to do the math with fractions. If you did it with decimals, it might have been a little bit hard to transform back to a fraction at the end, since all the answer choices are in fraction form, and that can definitely lead people to option D. I think that would be my guess as to why a lot of people are picking option D, is they have the decimal form, but then they make a mistake when transferring it back to fraction form. So just a small tip for sure, but it can definitely decrease the friction on these questions. And on harder versions of these questions, I've found it to be like very, very helpful. So last point, if you don't take the time to write out every term in an organized way, you might have arrived at 15/16 correctly, but then mixed up which term in the sequence comes directly before it. That's also a mistake I could see a lot of folks making. So like you get to 15/16, you think, cool, that one's less than one. What came right before that? Oh, 15/4. Like that's really, like, again, just like I was going to say comically easy, but like it's mistake to make, but it's like no laughing matter, you know. It's like given what's at stake here, this is serious business. So again, it might seem like that wouldn't happen, but it happens a lot. I think you might be surprised by how often folks do that kind of stuff, even really well-intentioned, super intelligent, like high-achieving people. So just recommending some simple good habits done consistently. And like a lot of areas of life, those can take you really, really far. It's definitely true with GMAT sequences questions, though. So just to recap, I recommend writing what's given every time, recommend writing what's asked every time, and then write out each term in the sequence to the best of your ability. Just try to keep it reasonably organized. Quick caveat on that, if there's 100 terms, just write out as many as you have time for. In general, I've found a good rule of thumb to be like if there's fewer than 20 terms, then it's good to just write them all out. If there's 100 terms, then maybe you write out like the first five and the last five. That can be a good bet. Or like the first five and then maybe the median, if it's like a median question and there's a list, and then the last five. That can be really, really helpful. And there's just something magic about that visual organization that really cuts down on the number of unforced errors that people make on these questions. So that's probably more than enough there. And hopefully we're warmed up on that. So if there are any notes to self that you want to make to remember for the future, I recommend texting or emailing yourself right now if you're on the go, or feel free to make that note if you're not. And then we'll move on to our next problem. Okay, feel free to pause. This one, apparently by the numbers, all of us find a little bit more challenging. The question says, in a certain quiz that consists of 10 questions, each question after the first is worth 4 points more than the preceding question. If the 10 questions on the quiz are worth a total of 360 points, how many points is the third question worth? I'll read that again. In a certain quiz that consists of 10 questions, each question after the first is worth 4 points more than the preceding question. If the 10 questions on the quiz are worth a total of 360 points, how many points is the third question worth? Option A is 18. Option B is 24. Option C is 26. Option D is 32. And option E is 44. Again, recommend pausing and getting as far as you can on your own. Okay, great follow-up question here, because pretty much everything we discussed in the previous question, except the fraction decimal part, can be applied super well here. I think the traps are a bit more difficult to avoid on this one, hence the slightly higher difficulty rating. In the previous question, about 85% of us get that one right. This one, only 79% of us get it. So not a crazy leap in difficulty, but a little tougher. So let's talk through how to apply some of those basic principles here, and then how those principles should help you excel on other questions that are similar. So first things first, and probably no surprise, let's write what's given and asked. We've got 10 questions. I would write that. Each is 4 points more than the previous one. I'd write that. So there, I'd probably use some half math, half English, like I was talking about earlier, just to capture the concept. So like 10 questions, each equals plus 4 points previous, something like that. Like it's not fully math, but it's not fully English. Something like that I've found to be really helpful for just helping me capture the logic of questions. And I think we've got a couple episodes where I talk through how valuable that can be on word translations in general. So definitely reach out and let us know if you'd like to hear a little bit more of that content as we go forward with some harder problems. You can reach us anytime at the GMAT strategy on current social channels if you like to DM, or you can email us. Our email address is contact, CONTACT, at thegmatstrategy.com. We know the 10 questions, sum to 360 points total, so I would write that as well. Again, probably half math, half English. Sum equals 360, something like that. And then we want to know how much the third question is worth. So I would write third question equals question mark or something like that. So note on that, I could definitely see myself mixing that up and solving for the first one. So I'd probably write that really big. Like I'd write third question, like larger than everything else I wrote. Or maybe I'd put like a big circle or box around it, whatever is going to help me remember. Like, don't just stop at the first one. And some of that comes from experience. Like I made that mistake many times. And then some of that is probably just like relatively intuitive, where you're like, yeah, under time pressure, if I like solve for the first one and I see it in the answers, I might just go for that. And I obviously don't want to do that when I'm one step away from getting the problem right. So it's kind of a fix the problem before it happens mentality. And that's usually a good mentality on questions that ask for things that are a little bit out of the ordinary. Like usually would be asked for the maximum or minimum of the set. That's more common. Asking for the third out of 10, that's a little bit weird. So that's a good cue that you should notate that to yourself, maybe more than normal. And I would do that for sure. That's the last reason I want to miss a question like this, and probably the same for you. So at this point, there's actually a few good strategic paths. I'm going to focus on one that I find to be the most fundamental of all the paths available for this kind of situation. But if you had a different approach that you felt worked really well, it's probably good. And just make sure it's working well for you consistently. The reason that I'm going to focus on the fundamentals here is that while there are a lot of like really slick things that you can do to potentially save time on questions like this, fundamental approaches like this one work way more often. They require far less memorization, so they're just simpler in general. And as a result, they tend to lead to fewer mistakes. So like if you know the question and you try one of the slick time-saving strategies, sometimes that can backfire. So just want to make sure you have an alternative if it's helpful. Last note on that, like as your skill set improves, you might get more comfortable with those faster approaches, and that's great. But I think you'll still be really happy that you have like a solid foundation that you can fall back on just in case. And that's what I've seen work the best over time. So what we're going to do for this very foundational approach is just create a variable for the smallest term in the sequence. It's something you can get a lot of mileage out of because a lot of sequence questions are similar to this one, where they start with an initial term that's unknown, and then they modify that term in some way. So like here we're adding 4, but it could have easily been like the third term is the average of the first two terms, or every next term is the average of the previous two terms. Like it's just a really, really common way for the exam to construct sequences. And so you can use this technique of like, let me set up some unknown variables for the first terms, and then I'll operate on those terms to see the rest of the sequence. In terms of how that would play out here, if I say my smallest term is equal to x as a placeholder, then the second term is going to be x plus 4. Third term is going to be x plus 8. Fourth term is going to be x plus 12, and on and on and on. We've got 10 terms like that. And going back to my point on the previous question, I would for sure just take the time to write out all 10 of those. It feels like it's going to take a really long time, but if you look at the clock time, it's like a few seconds. It's not that big of a deal to write them all out. Like I said on the previous problem, um, while there while there are a few shortcuts, I think that with writing out all the math here, you could definitely still reach your objective within 2 minutes. Sorry, I think I said that on the previous question, but we're just introducing that on this question. We got a little typo here, team. Thanks for bearing with us on that, everybody. So wanted to say that again, I already mentioned like it usually feels longer writing out all the terms than it actually is. So check your clock time. I mean, if you're the super slow writer type, then maybe that's going to be too slow for you. But if you look, I really believe you can get it right in less than 2 minutes with a little bit of practice. Maybe you're not going to be there right now or today, especially if you're just starting out. And I definitely didn't start out that fast. Um, but by by test day, um, if you have pen and paper and you're not doing it all in your head, that's also an important consideration for many of you right now. You can absolutely condition yourself to be able to do that in 2 minutes. And remember, test day is all that matters. Doesn't matter if you're slow right now. As long as you can hit it on test day in a reasonable amount of time, it's a good approach. So try not to worry if it feels slow at the moment. The first time we attempt most complex skills, they feel a little slow. And the third, fourth, fifth time, you should notice some measurable gains in speed. Okay, so let's pretend we've got the whole list written out here. The only piece of given information we haven't used yet is that the sum is 360. So let's just add our 10 terms, set those equal to 360, and let's see where that takes us. If I sum all the terms, since each one has an x value in it, I'm going to wind up with 10 times x as one of the terms on the left side of my equation. And if you're just getting started with your prep and you're not feeling good about your basic algebra and you want to reskill with that, we've got a math basics series to get you up to speed on that super fast, and that's going to be linked in the description of this content for you, okay? So we got 10x for all the x's. Then we're going to sum up all the other numbers that I wrote out. In this case, that's going to be 4 plus 8 plus 12 plus 16 plus 20 plus 24 plus 28 plus 32 plus 36. Again, kind of sounds like a lot, feels like a lot, but to write all that out, we're talking seconds, not that big of a deal. And if you sum all those numbers, they sum up to 180. So I can create an equation where the left side is 10 times x plus 180. That's the sum of all our 10 questions so far. And to the right of the equal sign, I can write 360 because I know that those two sums have to be equal. The problem told me that. From there, I can use some algebra to solve. I'll subtract 180 from both sides. That'll give me 10x equals 180 because 360 minus 180 is 180. And then I'll divide both sides by 10 to get x is equal to 18. Now, there's a big trap right there, and I talked about it earlier. The most popular incorrect answer is option A. And like I told you, like I really feel the gravity of option A in that moment where I'm like, oh, I got x equals 18. Yes, that's one of the answers. It's kind of like this excitement takes over. So it's probably not hard to see why a lot of us end up going for that. But that's not the answer because that's the value of the first question on the exam. And the problem is asking us for the value of the third question. So no problem to go for A. If you're going to make mistakes, make them in practice. But I would recommend reminding yourself to write what's asked really big at the start of every problem if you ended up making that mistake. Again, that's why I developed that habit for myself. It's worked super well for pretty much everybody I've ever helped out with this exam. And circle it, underline it, put a box around it, whatever you like, so that you're less likely to just choose the first answer that looks promising. So to get to the right answer, we want to look back at our list of values. We know the first value is 18. And this is also another good reason to make the list, to visualize the list and write out all 10 terms in the first place. Like I said, feels slow, but it's not that bad. And we'll figure out that the third question is going to be x plus 8 points. 18 plus 8 is 26, and that gets us to our correct answer of option C, as in Charlie. Now, that's the main pitfall there. A large percentage of us are going for A. Let me check the stats for you. Yeah, almost 10%. Almost 10 out of 100 of us are going for that. So preventable, but also an understandable mistake. So again, if you're going to make mistakes, make them in practice, fix them, and you'll be good on test A. We'll probably circle back on some of the shortcut and more advanced methods for these types of questions over time. But for now, I think it's a good idea to just consider the algebraic approach, be familiar with the algebraic approach, and get comfortable using variables and modifying those variables to represent the rest of the sequence. Works really well in a wide variety of situations. Like I said, it's simple to recall, and that usually makes it really worth having it in your toolkit. Like I said, if you had a better approach that you like, that you're getting great results with, stick with that. We're never going to argue with your results. Again, if there's a note to self to make for you there, I'd recommend making that now. And then we'll wrap up with one slightly more difficult question. And feel free to pause if you want to make that note. Final question here. The problem says if K is the sum of the reciprocals of the consecutive integers from 43 to 48 inclusive, then K is closest in value to which of the following? I'll read that again. If K, the letter K used as a variable, is the sum of the reciprocals of the consecutive integers from 43 to 48 inclusive, then K is closest in value to which of the following? Option A is 1 over 12. Option B is 1 over 10. Option C is 1 over 8. Option D is 1 over 6. And option E is 1 over 4. Again, recommend pausing there and getting as far as you can on your own. Really good, slightly more challenging question here. Like I said, by the numbers, it looks like this one's actually about 50% harder than the previous one. So about 20% of us are missing that previous question. About 30% of us are dropping this one. So decent amount harder in comparison. Let's explore how we can make questions like this a little easier for you and see if there's any transferable lessons you can leverage on future questions. First things first, many of the same principles of our first two questions apply equally well here. So let's start by writing what's given and asked, and then we'll create a visualization of the sequence. Side note, if you're just starting out and it's been a while since you thought about what a reciprocal is, we've got a whole math basics lesson on like those core definitions. It's the first lesson in that math basics series. So if you want to reskill or remind yourself of that stuff, I'd recommend going and listening to that and then returning here when you're ready. Good news on this problem is the sequence isn't too long. It's just 6 terms. So let's just write them out. It would be 1 over 43 plus 1 over 44 plus 1 over 45 plus 1 over 46 plus 1 over 47 plus 1 over 48. And now comes the strange part. And this is where things kind of diverge from the first two questions. trying to do an actual sum of those numbers is going to be hugely painful for most of us without a calculator. So in the previous questions, we were just going straight for the exact answer. This one is going to be a little bit different. There are a few alternatives, but I think the one that you're going to find to be the most useful and the most fundamental is just some light estimation. What we can do is establish a maximum and a minimum for the sum. And then what we can do is we can use those high and low estimations to choose among the options. The first time I saw this approach used, I was definitely really, really skeptical. And it made me feel super, super uneasy. So no worries if that's how you're feeling, or if that's how it ends up feeling. I think as you use the technique a little bit more, you'll start to see the value of it and you'll start to be able to trust it a little bit. So I'm just going to introduce you to it here. It's okay if you're like, whoa, I'm not feeling so great about that. Um, and again, there are alternatives, but I think it's a very worthwhile technique to talk through because it's helpful in very specific situations. I'll circle back to that in a second. So to estimate the low end of the sum, what we want to do is we want to take the smallest fraction and just pretend that all the other fractions have that exact same value as the smallest one. For sure, that will not give us the actual sum, but it's going to be way easier to do the math that way. And it shouldn't be too far off from where we want to be. So how would that look? 1 divided by 48 is the smallest value in the sequence because it's the largest denominator, and they all have the same numerator. So let's just pretend for a moment that all 6 terms on the list are 1 over 48. Again, makes the math a lot easier because we have a common denominator for all of them. It's just 1 over 48 plus itself 5 more times, and that's the same as 6 times 1 over 48, which would get us 6 over 48, which reduces to 1 over 8. And again, if it's been a while since you've reduced or multiplied fractions, that Math Basics episode will help a lot. So what does that mean? We took the smallest value, pretended all of them were that small. So 1 over 8 is for sure smaller than the actual sum. But notice the question is asking us which of the answers is closest to the sum. And it's worth knowing that on the GMAT, that generally means we're not going to be presented with a exact answer choice. They won't even give us the option of picking the exact answer for the sum. They're actually inviting us, maybe even forcing us to estimate. And I think part of it is testing your ability to deal with that uncertainty a little bit. I haven't spoken with anyone at GMAC about that, but it's reasonable to suspect that. Like in a lot of real world business situations, you might confront uncertainty. So maybe they're testing our ability to deal with it. Even if they're not, I think it's a positive frame to take for the question. So it doesn't just feel like this punishingly hard, inexact thing that's like torturing you. You know what I mean? I think it makes it feel like, okay, at least I'm like learning something that I'm going to use in the future. So we'll just note that. We'll note it as like minimum is 1 over 8. So 1 over 8, interestingly, is actually one of the answers. Let's just go ahead and check to make sure nothing is closer than that one. And a good way to do that is go for the maximum. So we just did the minimum. Let's do the exact same thing for the maximum value. So we're going to choose the largest of the 6 values, and we're going to pretend all of them are that value. So in this case, the largest one's 1 over 43. That's the smallest denominator. If we use the same approach, we would add 1 over 43 6 times, and that would get us 6 divided by 43. Unfortunately, that's not as clean, but 6 over 42 wouldn't be too bad, and that's 1 over 7. So that means 1 over 7 is definitely way too big, since that's bigger than even the largest estimate of the sum, because even 6 over 43 was too big. 6 over 42 would be even bigger. So now we're getting even further away from what the likely sum is versus our original estimate, low estimate of 1 over 8. Now, what's interesting there is 1 over 7 isn't even an option. The next highest value would be 1 over 6, but that's even further away. So it's way, way less likely that 1 over 6 is going to be the answer versus 1 over 8. And while 1/8 definitely is not the sum, again, coming back to like that probably feels really weird for most of you, it's at least equal to one of the endpoints of our range. And so that means we should pick 1/8, which is option C, as in Charlie, and that is the correct answer. Again, I find questions like this really unsatisfying and definitely nerve-wracking. Personally, I would rather solve for an exact answer. But again, we're not always given that option on the exam, and this problem's a good example of that. In fact, just knowing it's possible to see problems like this, I think, is a big advantage since being in the middle of your official GMAT and noticing that for the first time and trying to figure out if it's okay to pick an answer that's close but not exact, that's probably way more nerve-wracking. So we might as well confront it here. Beyond that, this estimation technique using like the high-low estimates for complex numbers or sums of complex numbers is also really, really valuable because even though it doesn't come up like quite as much as some of the earlier stuff we talked about, when it does come up, it's often the only viable way to do the problem in a reasonable amount of time. There's actually another problem in the old official guide. I don't remember if it's in this year's official guide. We can check on that. But it's a similar problem, and there's 100 terms. So this kind of estimation technique, ballpark approach becomes even more important, even more valuable. Maybe we'll get to that question later in this series. Okay, so those are some more knowledge-based takeaways, some more kind of higher level type takeaways. Expanding your perspective, making sure you're prepared for test day. But all the tactics of writing things out cleanly, making sure I'm doing my math properly, maybe those are even more important here in a question where I'm asked to be inexact so that I can be as exact as possible. That's especially important with fractions. So one final time, if there's anything there for you to note for later, I'd recommend pausing and making that note now. Like I said, if you have questions on any of this stuff, feel free to reach us anytime at the GMAT Strategy on current social channels, or feel free to email us contact@thegmatstrategy.com. If you're struggling with your prep and you're not seeing the results that you want to, or you're not seeing results as fast as you'd like to with your current provider, we specialize in speed of results, and we'd love to team up with you if it's a good fit on both sides. If you're interested in working with us directly or learning about any of our paid programs, just head to our website and check out our free video on how you can reach your dream GMAT score much faster, and that'll help you get a sense of our style. If you feel good about that, you'll be able to book a call with us to speak live and make sure that we're a great fit and that we're all confident that we're going to be able to hit your goals. There's no expectation or pressure or charge for the call. It's just an opportunity for you to understand what we do, see if it works for you, see if you like it. And if not, we'll be happy to set you up with some options that will work better for you. And we don't have any like referral relationships with anybody else in the space. So those are going to be really unbiased recommendations based on your situation. If you're not interested in any of our paid programs or booking any calls, that's totally cool. We're still super happy you're here, and we're happy to have even a small role in helping you make your dreams come true. And we'll be back soon with more free and valuable advice to help you accelerate that process. In the meantime, as always, stay positive and stay consistent with your studies. And I'm looking forward to speaking to all of you very soon.